Welcome back. I'm talking to Roger Anderton about the history of physics. Now, Roger just is going to show us a clip from a lecture given by Rupert Sheldrake. Now, this lecture, you said to me, was banned, Roger.
Yeah.
And was that because Sheldrake does kind of stray into the area of physics in his work, doesn't he? Because he's really trying to get to the nub of what's really going on in biology, and that leads him to physics. So I gather a physicist complained at what he'd said in this lecture.
Well, a scientist, it might have been a physicist.
Right. So it was taken off?
No, they banned it from the normal TED Talks.
Right.
TED is a collection of talks on by
Bill Gates.
Bill Gates, I have a lot of people on, and it's supposed to be promoting public understanding of science and so forth.
Yeah.
And there's too many protests about this. Sheldrake says lots of interesting things, and this is the bit I wanted to emphasise.
I want to spend a few moments on the constants of nature too, because these are again assumed to be constant. Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they'd changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away when the new values come out. They throw away the old ones. When I did this, I found that the speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop because they're given with errors of only fractions of decimal points of error. And yet, all over the world, it dropped, and they were all getting values very similar to each other with tiny errors. And then in 1945, it went up, 48, it went up again. And then people started getting very similar values again. I was very intrigued by this, and I couldn't make sense of it. So I went to see the head of metrology at the National Physical Laboratory in Teddington. Metrology is the science in which people measure constants. And I asked him about this. I said, what do you make of this drop in the speed of light between 1928 and 1945? And he said, oh dear, he said, you've uncovered the most embarrassing episode in the history of our science. So I said, well, could the speed of light have actually dropped? And that would have amazing implications if so. He said, no, of course it couldn't have actually dropped. It's a constant. So, well then how do you explain the fact everyone was finding it going much slower during that period? Is it because they were fudging their results to get what they thought other people should be getting, and the whole thing was just produced in the minds of physicists? We don't like to use the word fudge. I said, well, what do you prefer? He said, well, we prefer to call it intellectual phase locking. So I said, well, if it was going on then, how can we be so sure it's not going on today? And that the present values are produced by intellectual phase locking. And he said, oh, we know that's not the case. I said, how do we know? He said, we've solved the problem. And I said, well, how? He said, well, we fixed the speed of light by definition in 1972. So I said, but it might still change. He said, yes, but we'd never know it because we've defined the meter in terms of the speed of light. So the units had changed with it. So he looked very pleased about that. They'd fixed that problem.
Yes. So is he right there, Roger, do you think he's right there that the speed of light was a tiny bit different during different times in the last century? Would you go along with that, or do you
yes. What he's said here is that the person he was talking to admitted that it was an embarrassing thing that they didn't find that the speed of light was constant. Yeah. And Einstein says in his theory, special relativity, under those conditions of inertial motion, the speed of light is constant. And so if he's making that claim, you would then test that by experiment, and you would then decide whether what he was saying is true or not. But as he's admitted, as he pointed out, they were not able to measure the speed of light constant. And so to overcome that difficulty, they defined the speed of light constant. And so that's two totally different theories.
Right.
And I've been to a talk recently in America, and it's a Reg Cahill, and he's pointed out, he's done a really thorough analysis of the Michelson-Morley experiment and other experiments, and he's saying from the data which they're ignoring, the speed of light is not constant.
Yeah.
But he's also admitting into the problem of the dogma of the science community. They're not ready, they're not wanting to accept that the speed of light is not constant.
My understanding is part of the problem is in that everything, matter itself, is dependent on light and the speed of light, i.e. matter is actually trapped light, in my opinion. Matter is, so there's a paper, I don't know if you've seen it before, that suggests that the electron is a photon with toroidal topology. And that's what an electron is. It's a photon going around infinitely in a loop, right? So light and matter are interchangeable. E equals mc squared. So let me put this. How you perceive time depends on how fast your light is going around in your atoms. So if you move to a place where your atoms are going around twice as fast, for all time it appears to be going fast, you will experience it the same. So your clock is based on how fast your atoms go around, not on time itself.
What I mean here is that if you move to a place where light travels twice as fast, the atoms in your body will function twice as fast because the atoms are essentially trapped light. So you will function twice as fast. However, you will not notice this increased speed in your body's function because your perception of time is not based on an absolute value of time. It is based on the orbital period or motion of your atoms. So by moving to a place where light travels twice as fast, your time relative to somebody remaining at the other place will pass twice as fast. Your watch will run twice as fast relative to theirs, and you will age twice as fast relative to them. But your perception of your watch and your aging will remain the same to you. From this we can say that we as humans have no absolute perception of time at all. We only have perception of motion. This brings into question the very definition of time. If we have no real perception of time, can we really define what time is?
I would suggest that most instruments are based on atoms, therefore they're using, so if the speed of light increases and you've got an instrument measuring it, it won't see an increase. Do you see what I mean?
Well, Charles was pointing out that now that they're defining the speed of light as constant, if it does vary you wouldn't notice it because you've altered your instruments. You're altering your instruments to keep it constant. And so it's not really a proper scientific theory if you're doing that. It's people sort of like talk about a scientific theory from philosophers like Popper is where you test a theory to see whether it's true or not. And with a theory where you're defining something, you've taken that part of the theory out from being tested. And so it is sort of like bogus to define it like that. And if everything Einstein has been so influential, everything is coming from what Einstein has said. And one of his most fundamental things is about the speed of light. And if you suddenly say, well, the speed of light is not really constant, it throws everything else into chaos. So if Einstein is wrong, then you've got a mounting of paperwork, which is all nonsense.
My understanding is that light is a wave which is flowing through the medium of the vacuum of space. It's a pulse of energy flowing through space. So if that space changes in some way, its properties change, then the speed of that energy pulse, i.e. light, will change. I mean, to me, it's pretty... I accept that the speed of light is not constant, because doesn't space have a permittivity? And if that changes, then the speed of light will change, surely. So, now he talks about gravitation in this next clip, in the gravitational constant. But all of these constants, in my opinion, are dependent on space itself, and I think the role of space is underplayed in physics and in biology.
Yeah.
Because my opinion is, if you can understand the medium of space and the structure of space and define its behaviour, you will have a unified field theory.
Yeah.
It's about space, in my opinion. But we'll maybe come on to Nassim Haramein and people like that in a moment.
Everything is built upon Einstein, and if you got things wrong, then you go back to look for something earlier than Einstein. And so that's what I've done. I've gone back to look for earlier from Einstein, and I come up with, there was a unified theory of physics before Einstein. And so if Einstein is sort of like added lots of things on top which are wrong, then it's all been 100 years worth of diversion onto the wrong tactic.
Right.
And so they're trying to cover this up now with their dogma about defining the speed of light as constant.
The military-industrial complex who develop secret technology, do you think they know that the speed of light is not?
Well, if we're going,
do you think that they're working on a whole different set of formulae in the black world, or do you don't go along with that?
If you're looking onto this conspiracy side of things about what are they doing in the secret,
for example,
science, then they could be completely different to what is in the public domain.
But I said, well, then what about big G, the gravitational constant known in the trade as big G? It's written with a capital G, Newton's universal gravitational constant. That's varied by more than 1.3% in recent years. And it seems to vary from place to place and from time to time. And he said, oh, well, those are just errors. And unfortunately, there are quite big errors with big G. So I said, well, what if it's really changing? I mean, perhaps it is really changing. And then I looked at how they do it. What happens is they measure it in different labs. They get different values on different days, and then they average them. And then other labs around the world do the same, and they come out usually with a rather different average. And then the International Committee on Metrology meets every 10 years or so and average the ones from labs around the world to come up with the value of big G. But what if G were actually fluctuating? What if it changed? There's already evidence, actually, that it changes throughout the day and throughout the year. What if the Earth, as it moves through the galactic environment, went through patches of dark matter or other environmental factors that could alter it? Maybe they all change together. What if these errors are going up together and down together? For more than 10 years, I've been trying to persuade metrologists to look at the raw data. In fact, I'm now trying to persuade them to put it online on the internet with the dates and the actual measurements and see if they're correlated, to see if they're all up at one time, all down at another. If so, they might be fluctuating together, and that would tell us something very, very interesting. But no one has done this. They haven't done it because G's are constant. There's no point looking for changes. You see, here's a very simple example of where a dogmatic assumption actually inhibits inquiry. I myself think that the constants may vary quite considerably, well, within narrow limits, but they may all be varying. And I think the day will come when scientific journals like Nature have a weekly report on the constants, like stock market reports in newspapers. You know, this week, big G was slightly up, the charge on the electron was down, the speed of light held steady, and so on. That's one area, just one area where I think thinking less dogmatically could open things up.